The next concept is Ensemble uncertainty principle. Very important for 2 marks. Ensemble uncertainty principle statement. The Ensemble uncertainty principle says that it is impossible to measure both position and momentum for a moving electron. Simultaneously. Is called Ensemble uncertainty principle, and it is also says that the change in position and momentum is always greater than h by 2 pi. This also says that the change in position and momentum product is always greater than h by 4 pi. Is called Ensemble uncertainty principle. This is the statement. Either you write the first one or second one, both are right. So according to this definition, the mathematical expression is delta x into delta p is always greater than or equal to h divided by 4 pi. This is the mathematical equation. So observe here what we are saying. It is impossible to measure ಅಂದ್ರೆ ನಾವು ಮೆಜರ್ ಮಾಡಕ್ಕೆ ಆಗ್ತಾ ಇಲ್ಲ ಯಾವುದು ಪೊಸಿಷನ್ ಮತ್ತೆ both position and momentum for a moving electron. Already I told you, when electron is moving in a orbit, ಒಂದು ಆರ್ಬಿಟರ್ ಅಲ್ಲಿ electrons ಅನ್ನೋದು ಮೂವ್ ಆಗ್ತಿದೆ ಅಂದ್ರೆ ನಾವು ಮೂವ್ ಆದಾಗ ವೆಲಾಸಿಟಿ ಹೇಳ್ಬೋದು. when it is moving we can say the velocity of an electron, when it is rest we can say the position of electron, but we can't say both at the same time. It is simultaneously. So that is the definition given by uncertainty principle, that is Ensemble. And here the definition itself says that there is some uncertainty, and here the next definition is the change in position, where delta x is nothing but change in position. Delta x, that is delta x is equal to x2 minus x1, that is change in position. Similarly delta p, change in momentum, that is p2 minus p1 is the change in momentum. So those two products into here, that is called product, is always what greater than or equal, that is greater than h by 4 pi. This is the mathematical expression for Ensemble uncertainty principle. So after that we are going to study quantum mechanical model, that is the next concept is quantum mechanical model of an atom or wave mechanical model of an atom. Either you call quantum or wave. Here the scientist Schrödinger observed that the matter or the electron having both the wave character as well as particle character. Okay, that is said by the scientist de Broglie. Based on that concept, the scientist Schrödinger observed that the particles or electrons are substance having both wave character as well as particle character. Based on that, in a orbit, the electrons is moving in three-dimensional way. That is 3D way. The electrons are moving in a orbit, three-dimensional way. Based on that, give a mathematical equation that is called Schrödinger wave equation for a moving electrons in a three-dimensional manner. That is, the Schrödinger wave equation is d square psi by dx square and d square psi by dy square plus d square psi by dz square plus d square psi by h square into e minus v of psi is equal to 0. This is the Schrodinger wave equation. Schrodinger wave equation for a moving electrons in a three-dimensional region of an orbit. ಒಂದು ಆರ್ಬಿಟಲ್ ಅಲ್ಲಿ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ 3 dimensionally ಮೂವ್ ಆಗ್ತಾ ಇರುತ್ತೆ. 3 dimension means that you take 3 axes. One is x axis, another is y axis and z axis. Here in this orbital the electrons are moving like electrons ಅನ್ನೋದು ಈ ತರ ಮೂವ್ ಆಗ್ತಾನೆ ಇರುತ್ತೆ 3 dimensional means in all axis, x axis ಅಲ್ಲಿ y axis ಅಲ್ಲಿ z axis ಅಲ್ಲಿ 3 axis ಅಲ್ಲಿ ಮೂವ್ ಆಗ್ತಾ ಇರುತ್ತೆ. For that this Schrodinger given a wave equation that is d square psi by dx square, d square psi by dy square, d square psi by dz square plus d square psi by h square into e minus v of psi is equal to 0. This is the Schrodinger wave equation. Here where psi is wave function, this symbol we call as psi. This symbol we call as psi. That is this psi. This symbol we call as psi. And he is called energy of an electron. And v is velocity of an electron. You know psi is wave function and d square psi by dx square is the differentiation of psi with x axis. Differentiation of psi with x axis. So along with x axis we are differentiating, means we are dividing the psi, means wave. ಅಂದ್ರೆ ಇಲ್ಲಿ ವೇವ್ ಅನ್ನೋದು ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಅನ್ನೋದು ವೇವ್ ಫಾರ್ಮ್ ಅಲ್ಲಿ ಮೂವ್ ಆಗ್ತಿದೆ ಅಂದ್ರೆ ಒಂದ್ಸತಿ x axis ಅಲ್ಲಿ ಮೂವ್ ಆಗ್ತಾ ಇರುತ್ತೆ, ಒಂದ್ಸತಿ y axis ಅಲ್ಲಿ ಮೂವ್ ಆಗ್ತಾ ಇರುತ್ತೆ, ಒಂದ್ಸತಿ z axis ಅಲ್ಲಿ ಮೂವ್ ಆಗ್ತಾ ಇರುತ್ತೆ. ಅರ್ಥ ಆಯ್ತಾ? ಅದೇ ರೀತಿ ಪ್ಲಾಂಕ್ಸ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಇದೆ z ಸ್ಕ್ವೇರ್, ಸೊ h ಸ್ಕ್ವೇರ್ ಅದ್ರ ಜೊತೆನೇ ಮೂವ್ ಆಗ್ತಾ ಇರುತ್ತೆ ಅಂತ ಹೇಳ್ಬಿಟ್ಟು ನಾವು ಏನ್ ಮಾಡ್ತಾ ಇದೀವಿ, psi ನ ಅಂದ್ರೆ ವೇವ್ ಫಂಕ್ಷನ್ ಅನ್ನ 4 ಪಾರ್ಟ್ಸ್ ಆಗಿ ಡಿವೈಡ್ ಮಾಡ್ಕೊಂತ ಇದೀವಿ. That is differentiation of psi square with x square. Sorry, psi with x square, and this is also differentiation of psi with the y axis and differentiation of psi with z axis, and here differentiation of psi with h square, that is Planck's constant. Why we are not written z here, d here means h is Planck's constant, right? So that we get h square rather than h. This is the Schrodinger wave equation for an electron which is moving in 3 dimensional in an orbit. So here the electrons which is moving in an orbit and having maximum density at a certain position we call orbital. So orbital is a position in an orbit. This is what orbit. In this orbit where the electron density is maximum, that is called orbital. This orbital having 3-dimensional nature and it has a dimensional, but this orbit doesn't have any dimension and it is only 1-dimensional. Then the maximum number of electrons in this orbit is 2n square, but the maximum number of electrons in this orbital is 2 electrons only. Now we are going to know the difference between orbital and orbit. So orbital gu matte orbit gu ಏನು ಡಿಫರೆನ್ಸ್ ಇದೆ ಅಂತ ನಮಗೆ ಇವಾಗ ಗೊತ್ತಾಗುತ್ತೆ. That is after knowing the Schrodinger wave equation. So the next one, difference between orbital and orbitals. Here orbit is nothing but it is a circular path around the nucleus in which electrons is revolved. So here observe, this is an orbit around the nucleus, right? Inside that there is a nucleus, it consists of protons and neutrons. These are the orbits. There is so many orbits around the nucleus. These orbitals containing what? Electrons. So this is the orbit. This circle is called as orbit. It revolves around the nucleus in which electrons is revolving. In this orbit, electrons is revolving. Now, what is mean by orbital? It is the three-dimensional region in a space around the nucleus in which the probability of electrons is maximum or density is maximum or high. So here in these orbitals, ಈ ಆರ್ಬಿಟ್ ಒಳಗಡೆ ಇಲ್ಲಿರುವಂತ ಆರ್ಬಿಟ್ಸ್ ಒಳಗಡೆ ಒಂದು ಸ್ಮಾಲ್ ಸ್ಪೇಸ್ ಅನ್ನೋದು ಇರುತ್ತೆ, 3 ಡೈಮೆನ್ಷನಲ್ ಸ್ಪೇಸ್ ಇರುತ್ತೆ. ಆ 3 ಡೈಮೆನ್ಷನಲ್ ಸ್ಪೇಸ್ ಅಲ್ಲಿ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಮ್ಯಾಕ್ಸಿಮಮ್ ಆಗಿ ಇರುತ್ತೆ, ಅಂದ್ರೆ ರೆವಾಲ್ವ್ ಆಗ್ತಾನೆ ಇರುತ್ತೆ, 3 ಡೈಮೆನ್ಷನಲ್ ರೆವಾಲ್ವ್ ಆಗ್ತಾ ಇರುತ್ತೆ. ಈ ಆರ್ಬಿಟ್ ಒಳಗಡೆ ಒಂದ್ ಕಡೆ ಜಾಸ್ತಿ ಹೊತ್ತು ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಅನ್ನೋದು ವೇಟ್ ಮಾಡ್ತಾ ಇರುತ್ತೆ. ದಟ್ ಪೊಸಿಷನ್ ಕಾಲ್ಡ್ ಆಸ್ ವಾಟ್? ಆರ್ಬಿಟ್. Okay, then it is represent movement of electrons in one plane. So observe these orbitals indicates only movement of electrons in one plane, right? But these orbitals represents the movement of electrons in three-dimensional in a space around the nucleus ಒಳಗಡೆ 3-dimensional space ಅಲ್ಲಿ revolve ಆಗ್ತಾ ಇರುತ್ತೆ. So after knowing the difference, you know the complete clear clarification about the orbitals. Now it is spherical in shape. So observe here, this is spherical in shape. This orbit is spherical in shape, but these orbitals having different shapes. That is either spherical shape or dumbbell shape. This is the dumbbell shape, like a 8 dumbbell shape, and double dumbbell shape. Double dumbbell shape means like that. This is the double dumbbell shape. And this is the complex. Complex means we can't write difficult. That is called complex. So observe here, this is three-dimensional. This circle ಅನ್ನೋದು ಒಂದು sphere ತರ ಇರುತ್ತೆ. Sphere, not a circle. Actually, spherical means it is a sphere. Not we are saying circle. Means we are not saying circle. We are saying spherical. Spherical means it is like a ball. In ball, we can see three-dimensional, right? Similarly, this is like 8. It means it is also having spherical in shape, means two spheres becomes fused together and we get dumbbell shape. Okay, this is also having electron 3-dimensional region, hence these are 3-dimensional space around the nucleus. Then the fourth one, the maximum electrons in an orbit is 2n square, where n is equal to 1, 2, 3, so on. Means if n is equal to 1 square is 1 and having 2 electrons only. If n is equal to 2 square is 4 into 2 8. Means 8 electrons. Like the number of electrons in the orbit is calculated by using 2n square, and similarly the number of electrons in the orbitals is always 2 only. ಒಂದು ಆರ್ಬಿಟಲ್ ಅಲ್ಲಿ ಎಷ್ಟು ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇರುತ್ತೆ ಅಂದ್ರೆ ಮ್ಯಾಕ್ಸಿಮಮ್ 2 ಮಾತ್ರ ಇರುತ್ತೆ ವಿತ್ ಆಪೋಸಿಟ್ ಸ್ಪಿನ್. Okay, this is the difference between orbit and orbitals. Now after the next concept means after knowing the difference, we are going to study the concept of orbitals. What are the types of orbitals is there? Like spherical, dumbbell, double. These are represented for what and how many electrons, and what is its shape, and what is the value of azimuthal quantum number L. These are we are learning. That is shapes of orbitals. The next concept is shapes of orbitals. There are 4 shapes of orbitals. That is S, P, D and F. There are 4 types of orbitals: S, P, D, F. This is the shapes of orbitals, or we are generally represented 4 types of orbital. By using those, we can write the electronic configuration of various elements. Okay, now the shapes of orbital. The first one is S orbital. This S orbital is non-directional. There is no direction for S orbit, and it is spherical in shape. Then its L value is 0 and M value is also 0. For S orbital, L value is 0 and M value is also 0. means L is nothing but azimuthal quantum number and M is magnetic quantum number. So L is azimuthal, M is magnetic quantum number. For this, the s orbital is spherical in shape. This is the s orbital. Spherical in shape. Here, the electron density in s orbital is arranged or spread uniformly. Electron density in s orbital uniformly shared. This is the s orbital. So remember, s orbital is non-directional and spherical in shape. Its L value is 0 and M value is also 0. This is the representation. And the electron density is shared or occupies or distributed uniformly. L is azimuthal quantum number and M is magnetic quantum number. And for second orbital, that is p orbital. This p orbital is directional. P orbital is directional and dumbbell in shape. It is dumbbell in shape. The dumbbell shape is represented like this is the representation of dumbbell shaped p orbital. For this one, the electrons are not distributed uniformly. Electron density is not distributed uniformly because observe here there is a touching of these two like a 8. Actually, this is not like a 8. When we are taking a ring and we are twisting, you get a shape like that. That is actually the dumbbell shape. Here, the electron density is not distributed uniformly, but in s orbit it is distributed. For this one, the L value is 1 and the M value is -1, 0 and +1. It means there is 3 orbitals. ಇದರಲ್ಲಿ p orbital ಅಲ್ಲಿ ಎಷ್ಟು orbitals ಇದೆ? 3 p orbitals ಅಲ್ಲಿ. m ಅಲ್ಲಿ s ಅಲ್ಲಿ ಎಷ್ಟಿದೆ? ಒಂದೇ ಇದೆ ಅಂತ 1 orbital. ಇದರಲ್ಲಿ p orbital. So while writing the electron configuration, we are writing like boxes, right? Are you remember or recalling? Like in s orbital we are writing 1 box, but in p orbital we are writing like 3 boxes. This is only based on the magnetic quantum number, that is -1, 0 and +1. Similarly, the next orbital is d orbital. D orbitals. This d orbital also directional. This d orbital is also directional and its shape is double number. The shape is double number. The shape is double number. It means its shape is like that. One double. Double means 2. Like that. 2 dumbbells. This is the shape of d orbital, and here also the electron density is not occupies uniformly. Means not distributed uniformly. Only s orbital is distributed uniformly. Then in p, d or f orbital is not distributed uniformly. So this is the shape of d orbital, and for the d orbital the L value is 2. L value is 2, that is 0, 1, 2. This is the L value. Then M value is -2, -1, 0, +1 and +2. There is 5 values in d orbitals. For M, that is magnetic quantum number having 5 values, hence it having 5 orbitals. 5 orbitals irutte, ಯಾವಾಗಲೂ d orbital value. Then fourth one, f orbital. There is f orbitals, p orbitals, f orbitals. This f orbitals is also directional. So observe what is mean by directional. If you write an axis here, so observe the right here, one is x axis, one more is y axis. But here there is only one axis, either it may be x or y or z, any one axis. But in spherical we can't write an axis. So if observe, if I write like that, it becomes x. If I write y, if I write like z, it means it is not in any one direction. It means it is present in all directions, hence we call non-directional. Similarly, f orbital is also directional and its shape is complex. Complex means difficult. We can't able to write the shape of the f orbitals, means unable to write, hence called complex in shape, and the values of L for f orbital is L is equal to 3. Okay, after 2, 3. Then m values are you expected? How many you get? So m value is -3, -2, -1, 0, +1, +2, and +3. So there is 7 orbitals in f orbital. F orbitals is 7 orbitals in there. That is 1, 2, 3, 4, 5, 6, 7 orbital. So that while writing the electronic configuration, when you get f orbital, you write like that 7 boxes. Like 3, 4, 5, 6, and 7 boxes. So similarly, while writing the orbitals, we can write like that 5 orbitals. 2, 3, 4, 5, like that. Okay, these are the orbital shapes of orbitals. This concept is came under the mechanical quantum number or wave quantum number. That is quantum mechanical model of an atom or wave mechanical model of an atom. That is proposed only this coordinate. Before that, we don't know what is the concept of orbitals and the complete structure of an atom. So that quantum mechanics helps lot to understand the complete structure of an atom. Using this, we can predict many concepts and how the atoms combine together and form molecules, and how those concepts are how the compounds is formed, and what are the chemical physical properties will be changes when, and how we get isotopes, isobars, isotones. All those concepts will be understand easily after knowing this Schrodinger's wave equation and this quantum mechanical model and shapes of an orbitals. Okay, so I hope you understand, students. So remember, the shapes of an orbitals is very important, and they may ask L values and M values for any one of the orbitals. Here the most important is the S, P and D orbitals. For those only they ask the L values and M values.